This video will identify the role of the network layer as it describes communication from one end device to another. It will also examine the Internet Protocol, or IP, which is the most common network layer protocol. The information in this video will explain the principles used to guide the grouping of devices into networks, hierarchical addressing, and how a packet routes through the network. The network layer, or OSI Layer 3, provides services for the exchange of data over the network between end devices. Layer 3 uses four basic processes: addressing, encapsulation, routing, and decapsulation. First, the network layer must provide a mechanism for addressing these end devices. If data are to be directed to an end device, that device must have a unique address. Second, the network layer must provide encapsulation. During the encapsulation process, Layer 3 receives the data from the transport layer in a Layer 4 PDU and adds a Layer 3 header, or label, to create the Layer 3 PDU, which is called a packet. Next, the network layer must provide services to direct these packets to their destination host. The source and destination host are not always connected to the same network. As the packet moves from network to network, perhaps over the Internet, it may traverse many intermediary devices. As the packet is forwarded, its contents remain intact until the destination host is reached. When the packet arrives at the destination host, it is processed at the network layer. The host examines the destination address to verify that the packet was addressed to this device. If the address is correct, the Layer 3 IP packet is decapsulated by the network layer, and the Layer 4 PDU contained in the packet is passed up to the appropriate service at the transport layer. For these processes to function properly, there have to be appropriate protocols in use. For the network layer, the most common protocols include Internet Protocol versions 4 and 6, usually referred to as IPv4 and IPv6, Novell Internet Packet Exchange, or IPX, AppleTalk, and Connectionless Network Service. In this video, we will focus on IPv4 since it is the most common network layer protocol in use today. IPv4 is currently the most widely used version of IP. IPv6 is being implemented in some areas and will operate alongside IPv4, and eventually it will replace it. IP was designed as a protocol with low overhead. It provides only the functions that are necessary to deliver a packet from a source to a destination over an interconnected system of networks. There are three main characteristics of IP protocol. It is connectionless, provides best effort delivery, and is media independent. Connectionless means that no connection is established between the source and destination before sending data packets. Best effort delivery means that IP does not guarantee packet delivery, so it is possible that a packet may be lost in transmission. It is the job of the transport layer to guarantee delivery. Media independent means that IP operates independently of the medium carrying the data and can be used with many different media. These characteristics greatly reduce the overhead of a packet, which allows IP to function very efficiently at the network layer. IPv4 encapsulates or packages the transport layer PDU into the Layer 3 IP packet so the network can deliver it to the destination host. You can think of the IP packet as an envelope that surrounds the transport layer PDU as it travels through the network. The IPv4 packet remains in place from the time that packet leaves the network layer of the originating host until it arrives at the network layer of the destination host. IPv4 specifies many different fields in the packet header. You may wish to study the IP packet more closely, but for now, note that the source address and destination address fields are crucial to delivering the data to the intended destination. One of the major roles of the network layer is to provide a mechanism for giving a unique address to each host. As the number of hosts on the network grows, more planning is required to manage and address the network. Rather than having all hosts everywhere connected as one vast global network, it is more practical and manageable to group hosts into specific networks. As shown in this graphic, networks can be grouped based on factors that include geographic location, purpose, and ownership. Grouping hosts at the same location, such as each building on a campus or each floor of a multi-level building, into separate networks can improve network management and operation and would be an example of grouping by geographic location. Dividing networks based on usage facilitates the effective allocation of network resources, as well as authorized access to those resources, and this would be an example of grouping by purpose. Using an organizational basis for creating networks assists in controlling access to the devices and data and eases the administration of the network. Finally, dividing hosts into separate networks provides a boundary for security enforcement and management of each network, and this is one reason to group based on ownership. IP addresses are hierarchical in nature. That is, part of the address represents the network, and part represents a specific host on the network. An IPv4 address is 4 bytes, which is divided into 2 parts, the network portion and the host portion. In this example, the first 3 bytes of the address is the unique identifier of the network, in this case, the 192.168.18 network, and the last byte is the unique identifier of the host within that network, in this case, the .57 host. In this network, all devices will have the same first 3 bytes in the address. Routers forward packets from one network to another by only using the network portion of the address. When the packet arrives at the router where the destination host resides, the whole address, both the network portion and the host portion, will be used to deliver the packet to the right host within the network. If the network portion of the destination address of the packet is different from the network of the originating host, the packet has to be routed outside the original network. In order to leave the original network, the packet is sent to a gateway, also sometimes called a default gateway. This gateway is a router interface connected to the local router. The gateway interface has a network layer address that matches the network addresses of all the hosts in that network. The hosts are configured to recognize that as the gateway address and use it anytime they need to send packets outside of the local network. You see the vital role the network layer of the OSI model plays in networking. Even its name, network layer, reflects the indispensable role in networking. IPv4 is the most common network layer protocol used today. As your understanding of networking increases, you will learn to work with IP addressing schemes to provide reliable, manageable, scalable, and secure networks to organizations that depend on them.